Hello everyone, welcome back to my class. In this video we are still talking about mathematical modeling. We have solved question number 1 and 2 of the past question, so we are going to talk about question number 3. Okay, so question number 3 now on mathematical modeling. Question number 3 said okay, question number 3a, this is 3a. They say given a logistic continuous growth model. Okay, they gave it as the n over the t is equal to Rn in bracket of 1 minus n over k. Okay, so they now say determine the solution of the above equation. Okay, so then question number b said okay, let me solve this, then I want to write question number b. Okay, or let me just write it. They said that as t approaches infinity, okay, they say we should describe the type of the solution. I mean the type of the solutions for the logistic model. Okay, when r is for I, when r is less than 0, I, when r is equal to 0, I, when r is greater than 0. Okay, so the C part of it, let me go down. C, the C part of it said we should determine the equilibrium point, equilibrium point of the logistic model. So determine the equilibrium point, that is Ci. The I of it said we should determine the stability. Then I said we should interpret the solution. Okay, now to solve this is very easy. Solution. So the first thing they say we should do is to solve the equation, and the equation they gave us is the n dt, okay, is equal to Rn in bracket of 1 minus n over k, like this. Now if you look at this, obviously this is first order differential equation, and first order differential equation, obviously this is separable. We can separate this, obviously. So to separate this, or using variable separable, so we're going to have that all the n will come one side, and then all the t will go one side, and obviously we don't even have t, so the only thing is just to bring all the n this side, and then this t should go to this side. Okay, so that is it. So the t can stay with the arrow, then let all the n come down. So I'm going to have 1 over n into 1 minus n over k, like this. Okay, the n is equal to r dt. Okay, now you have separated it. So the next thing to do is let us solve here. If we solve here now, you see that obviously if we multiply this is going to be 1 over n into, multiply this by, you have k minus n over k. I hope you know, obviously this time this divided by everybody. So because if you separate it, this is, let me show you what I mean. This is k minus n over k. If I separate this, it's going to be k over k minus n over k. So k over k is same thing as 1 minus n over k. So this is the same thing as this. Okay, so I did not change anything. So the n is equal to r dt. Okay, so having this, the next thing we do is, remember that this k can come up. This k that is down here can come up. 1 over 2 over 3. The 3 can come out to have just 3 over 2. Okay, so the k can go up to have k over n into k minus n, like this. The n is equal to what? R dt. Okay, so now we can now put integration sign. So we now have the integral of k over n into k minus n dn is equal to the integral of r dt. Now obviously this is integration by partial fraction, so we have to resolve this partially. So I don't know if I should start solving partial fraction here. Okay, let me just solve it for those that cannot remember the amount 101. So partial fraction, I'm having k over n into k minus n is equal to, say, a over n plus b over k minus n. Why? Because this is linear, so the above here is going to be a constant. I have a video on partial fraction, you can watch it if you don't understand. Here is equally linear, the above will be constant. So solve this right hand side. I'm going to have k over n into k minus n, okay, will now be equal to, the LCM here is n into k minus n. So when the both of them divide, this is remaining k minus n. K minus n times a, I'm going to have a into k minus n, okay, plus when this divide is remaining n times b, I have bn. So when the denominator take care of the denominator, I'm having that k is equal to a into k minus n, then plus bn. Okay, so if I open this bracket, I'm going to have k is equal to ak minus an, then plus bn. Okay, so in this case now, you will say the n is the main variable here. So everybody that has n, you equate it to n in the left hand side. So you're going to put equivalent here. We are now equating. So anybody that has a in the right hand side minus a has n, sorry, and then b has n. So these are the people that has n in the right hand side. So who has n in the left hand side? Nobody. So that's why I'm going to equate it to 0. Okay, you call it your equation 1. Now in the right hand side, who does not have n is ak. ak does not have n. ak does not have n is equal to, who does not have n in the left hand side is k. K does not have n in the left hand side. So if this cancel this, obviously my a is equal to 1. So if a is equal to 1, if I put 1 here, I'll see that minus a plus b is equal to 0. So minus 1 plus b is equal to 0. So obviously b is 1, right? Okay, sorry, is b 1 or minus 1? This is coming here. Okay, b is equal to 1 as well. B is equal to 1. So a is equal to b, which is equal to 1. Okay, so having this, you now come back and put it here. So that means that, permit me to draw the line here. That means that k over n into k minus n is the same thing as saying 1 over n plus 1 over k minus n. Okay, so that is the main reason we want to split this so that it will be easy to integrate. So my integration will now be, instead of writing this one, it will now be the integral of 1 over n plus 1 over k minus n. Okay, I can all the n is equal to the integral of, I think, r dt. Yes, r dt. Okay, so integration of this, differentiate the denominator. Once you get the numerator, your answer becomes ln that denominator. Differentiate the denominator. Once you get the numerator, the answer becomes ln the denominator. We got minus 1 when I differentiated. That is the essence of this minus here. Differentiation of this denominator with respect to n is giving me minus 1. That is this here. So, and it's just that 1 on top here. So we now say ln this, okay, is equal to what? Integration of this will give you rt plus a constant. So now, according to logarithm, if you have minus in logarithm, what does it mean? It means you should divide. So this is going to be ln n over k minus n is equal to what? rt plus a constant. Permit me to go to the next page because this has gotten to the last page. So let me come to the next page. So remember this so that we can write it. Okay, let me write it again. Okay, so we have ln n over k minus n is equal to is equal to rt. Where's my erase? Okay, So is equal to what? RT plus C. RT plus C. So we want to make n subject here, so that's our main aim. So when exponential move to the other side becomes, sorry, when logarithm move to the other side becomes exponential. So I'm having n over k minus n is equal to exponential RT plus a constant like this. So this is now n over k minus n is equal to exponential RT multiplied by exponential C, because the reason of addition in indices is multiplication, and the exponential of a constant is equal to a constant. So let me use a constant a. So therefore n over k minus n is equal to a exponential RT. Okay, so now from here you make your n subject of the formula, but if you cannot make any subject of the formula here, you can leave it like this as your answer. Yes, they can, I think they can award you your mark from here, but the main thing is now to make n subject of the formula. Okay, so to make any subject of the formula here, I'm going to have cross multiply n is equal to what? A exponential RT in bracket of k minus n. So open bracket to have that n is equal to what? AK exponential RT minus AN exponential RT. So this n will go to the other end to have n plus AN exponential RT is equal to AK exponential RT. So now if you simplify here, they have n in common. So I'm going to have 1 plus A exponential RT is equal to AK exponential RT. So if you make any subject of the formula now, n of t is equal to what? This one will come down. So I'm having AK exponential RT all over 1 plus A exponential RT. Okay, so that is that for that, and that is your solution. So but let's apply the initial condition, the initial population. So if we apply the initial population, what do we have using the initial population? So initial population, we have that n naught is equal to 0. The initial population, there was nobody there in the initial population. So that means if we put, or we can say n of 0 is equal to 0. Okay, is that what they give? No, sorry, what did they give for initial population? Okay, n of 0 is equal to n naught. Sorry, they did not give it to you. You need to do it yourself. So the initial population is that n of 0 is known as n naught. Okay, n naught. So that means if I put n naught here, I'm putting t to be 0 here. So if I say n of n naught or n of 0, I call it n of 0 or n naught, but let me just call it n naught. Okay, I hope I'm not fast though. Please, if I'm fast, you can rewind it. I'm sorry about that. So you have n naught is equal to, want to put anywhere we see t, we put here. So we have that this is what do we have? We have AK exponential r into 0 all over 1 plus A exponential r into 0. Okay, all right, so what do we have now? Or let us even put it here. Here will be easier. Don't you think here will be easier? Here will be easier. So let us just put it there. Or the same thing, n naught will now be equal to, so n to the raised power 0 is 1, n to the raised power 0 is 1. I have AK over 1 plus A. Okay, AK over 1 plus A. So what do we have now? If you now put it back there, what do we have? I wish I'm not making mistake anyway. Okay, so this is our initial population. So where do we substitute that? We're supposed to substitute somewhere. Okay, we want to get our A from the initial population. Yes, that is the main aim. The main aim is to get A from the initial population. So from here, let us get our A, sorry. So to get your A, you have that n naught in bracket of 1 plus A, okay, is equal to AK. So therefore, this time you have n naught plus n naught A is equal to AK. So let's say this one coming to this side, I'm going to have n naught A minus AK. Or what am I saying? Sorry. I want the other one to move to the other side. Let me clean. Okay. So N naught A, no. Sorry. So let me move this one to the other side to have that N naught is equal to what? AK minus N naught A. Okay. So therefore, if I open the bracket, you see that N naught will now be equal to A into K minus N naught. So therefore, my A will now be what? A naught over K minus N naught. So this is my A. So if this is my A, remember that my this thing, the general equation I got was NT is equal to what? NT is equal to AK exponential RT all over 1 plus A exponential RT. This was what I got. So let me now put this. If I put this, I'm going to have N of T will now be what? N naught over N naught over, how do I put this? N naught over K minus N naught, then K here exponential RT, okay, over 1 plus N naught over K minus N naught exponential RT. The equation is too big, so how do we shorten it? How do we shorten this equation? Okay, the way we are going to shorten this equation is to reduce this one first. So let me clean and then reduce this one. So I have from here, let me start from here so that you will not get confused. Sorry, just follow me gradually. So I have that now my N of T is equal to what? My N of T is equal to AK exponential RT over 1 plus A exponential RT. Was that what I got? Let's check. Okay, yes. So now divide everybody by, you see, I'm having the same exponential RT, A exponential RT. So divide everybody by the same A exponential RT. So I'm going to have that N of T will now be equal to AK exponential RT over A exponential RT all over 1 over A exponential RT plus A exponential RT over A exponential RT. So if everything here cancel everything here, so I'm having that K is on the numerator all over. So this one can be written as A raised to power minus 1 exponential minus RT then plus 1, because everything here is 1 here. I have reduced the equation normally, so I can now put my A. You understand? You can now put your A. So I'm having that my N of T is equal to K over my A. Remember what I got my A to be. My A is this. So if my A is this, therefore A minus 1 will now be to turn this upside down, which is K minus N naught over N. So let me now put it there. K minus N naught over N naught. So this is K over N minus N naught. Sorry, K minus N naught over N naught then plus 1. Okay, so I think, okay, sorry, there is an exponential there. Okay, with the exponential, sorry, there is exponential in bracket of exponential minus RT. So this is my equation. I hope it's not difficult. It's not difficult, it's just that the way I'm trying to make things easier, it's not difficult at all. You can just calm down and go through the video again. And if you're writing it by yourself, you see that all these things are just normal mathematical terms. They are not the main thing. It's just normal mathematical, basic mathematical expression. So let's go to question number 3B. Okay, question number 3B. So, and that question number 3B said, so question number 3B, remember it said that we should what they say we should do for question number 3B. Question number 3B said that at t tends to infinity. So we should check when r is greater than 1, when r is greater than 0, and greater than this and greater than. So the first one they say we should check is that if r is greater than 0. Now if r is greater than 0, it will show that if you see my equation, let's go to the previous. Let me write down my equation. Okay, let me write it down. This is the next. So my equation was that n of t is equal to what? K over 1 k over what? K minus n naught over n naught all exponential rt plus 1. Okay, now when r is equal to 0, and the only place we have r is here. Okay, there is minus here. So if r is greater than 0, that means r is positive. It's going to make this man to be going to be moving close to 0. Okay, so if r is greater than 0, that means r is positive. That is from 1, 2, 3. So it's going to make this to be 1 over exponential rt like this. So this thing now will be getting closer to 0, because 1 over exponential 1 over exponential 2 like that, it will be going closer to 0. So this will make exponential minus rt tends to 0. And if it tends to 0, you see that everything here will now be 0. So if everything here will be 0, I'm left with k over 1, and k over 1 is what? K. So which means that n of t will now be approaching k. You see the analysis. So if it's approaching k, what do we now say? The conclusion, because they asked us to interpret it, right? They asked us to do what? We are asked to, okay, so to interpret it, we just say that what? That the population approaches the carrying capacity. Okay, the population approaches the carrying capacity. This population, this is the new population, is approaching the carrying capacity. That is for the first one. Now for the second one, they say we should analyze for r being equal to 0. Now if r is equal to 0, what do we see? If r is equal to 0, obviously we are going to have that when r is 0, if here is 0, e raised to power 0, I'm going to have k over this. I think I'm going to have n naught. Yes, n of t will now be equal to n naught. Yes, n of t will now be equal to n naught. Okay, and we call it constant. Yes, we call it constant. It doesn't change. The initial population remains the same. So the third one is when r is now less than 0. If r is less than 0, what happens? You will notice that if r is less than 0, notice that here, if r is less than 0, that is r is now negative. Well, we will now have that 1 over exponential negative, exponential positive something here. We will now make everything here to tend to infinity. Okay, so when r is less than 0, it will make e raised to power minus rt to approach infinity. Okay, if it approaches infinity, what happens? If it approaches infinity, if here approaches infinity, then everything here becomes I think it will be 0. Yes, if it approaches infinity, I think I'm going to have here to be 1. Here to be negative 1, I think. Let me see. No. If this approaches infinity, what happens? I'm going to have, what are we going to have here? I think the population, if it approaches infinity, the population will approach 0. Please, if it approaches infinity, the population approaches 0. And then what do we say? The interpretation is that the population dies out, it moves to extinction. So please take note of that. Okay, so the third one is now the stability. We are asked to calculate the stability, that is 3c. So to calculate the stability and the equilibrium, so first of all you determine the equilibrium, and I told you at the equilibrium the n, the t must be equal to 0 at equilibrium. So remember they gave us that the n, the t is equal to what? Is equal to Rn in bracket of what? 1 minus n over k is equal to what? We are equating it to 0 because we want to get the stability. So when the two of them is equal to 0, we know that Rn is equal to 0, or 1 minus n over k is equal to 0. So finally we are having that what? n is equal to 0, or 1 is equal to n over k, which shows that n is equal to k. So the stability point is what? So sorry, at equilibrium, at equilibrium, our n is equal to 0 and k at equilibrium. So now let us now check the stability of each of these. Okay, so let's check the stability of each of these. So for the stability, remember I told that the only thing that will make something to be stable is when the absolute value of the first derivative, okay, when the absolute value of the first, we are going to get the absolute value of the first derivative. So we say stability. Okay, for the stability we are going to have, let's first of all find f prime of n star. Okay, and f prime of n star is the same thing as the function we are given, because it is the y dx, the n dt, which is same thing as f prime. So we have that r n into 1 minus n over k. Okay, now we open the bracket. If we open the bracket, we are going to have r n minus, this time we have r n squared over k, right? So okay, so let this be our function. No, this is our function, not this is the main function we are given, not its derivative. So this is the main function we are given. So we can now find its derivative. Let us find its derivative. So f prime of n star will now be differentiate this to have r, differentiate it to have 2n over k, 2rn over k, okay, 2rn over k. So this is where we will now start testing our stability. So the first one is we'll test when n is 0, then we'll test when n is k, and know what we are going to have. So when n is 0, when n is equal to 0, so we now have that f prime of 0 will now be equal to r minus 2r into 0 over k, so which is just giving us r. So if you give us r now, we will now check the stability now depends on what r is. So if r is greater than 0, what do we say? Is this stable or unstable? If it's greater than 0, what do we say? Stability, are we checking greater than 0 or greater than 1? Sorry, if it is greater than 1, not greater than 0. But anything that is greater than 0 is still greater than 1. So but let's say greater than 1, I think. Correct me if I'm making mistake, please. I think it's greater than 1 is stability. I think we did something like that. In the second video we solved something like stability in the second video. When we define stability, I think it's greater than 1. So see, if it is greater than 1, if this is greater than 1, we say that it is unstable. Okay, so if r is less than 1, we say that it is stable. So now if r is equal to 1, we say that it is what? Neutral. So that is that for the first one. So let's test when k, I think we have gotten to the last point in next page. So the next one now is we now test when k is equal to, so when n is equal to k. That's the next one we are testing. So when n star is equal to k, we want to test the stability of this one. So we have that f prime of that k, okay, is equal to what? R in bracket of 1 minus 2k over k. Okay, so we're going to have that this is what? R in bracket of 1 minus 2, so which will give you minus r. So and minus r. So from here now, since we have minus r, what do you say? So the first thing is that if r is greater than 0, if r is greater than 0, that means r is positive, and if you put it here, it will give you negative. So we say it is stable. Okay, so another one is that if r is less than 0, it will not be negative. Negative will give you positive, so we say unstable. Okay, so if r is equal to 0, then neutral. So know that this one is like the opposite of the other one. So this one is just like the opposite of the other one. Okay, so I think that is that for question number 3. If there's any question, just ask me on the comment section. Okay, thank you very much for watching. Please don't forget to like our video, share our video, subscribe if you are new to the channel. May the peace of the Lord be with you. Bye bye.